Aloha and welcome back, everyone. We've just been talking about the nature of matter and the idea that scientists came to understand that matter could be broken down into only a certain smallest particle, and we're going to be giving that a name in just a minute, but we're going to continue with this video segment with some of the evidence for what we call the particle model. That is the early evidence for the belief that matter can be broken down only into a certain smallest piece. So atomism is a name for the belief that there is a certain smallest piece of matter, and one of the beliefs of atomism is that particles are in constant motion. These smallest pieces of matter are constantly jittering around, and a good way to illustrate that is if you take a glass of water, okay, like we have right here, a glass of water, and if you drop here I have a colored crystal, but it could be a colored food dye or whatever it is. If you drop it in that water, now of course if you drop it in the water, it makes the water ripple a little bit. But even if you just touched it to the water very, very gently, so that you really didn't disturb any of the water itself, you would still see the food dye actually start to kind of fill the water, even though you only dropped it at one little place. Like right here, you see the red kind of swirling around, and then you got the blue and then the green. The reason that it does that is because all of the particles of water are constantly in motion. We call this diffusion. All right, these colors are being diffused in the water, even though the water really isn't moving that much. Another bit of evidence for the particle model is in the 1700s. Scientists discovered that as you burn matter, it weighs different amounts before and afterwards. So the idea was that burning causes particles of matter to combine in different proportions, such that they actually weigh less after after the burning. All right, after this combustion process right here. So these things are kind of early bits of evidence for the particle model. Aloha and welcome back, everyone. In this chapter on matter, we have been talking about, let me stop that for a second. Aloha and welcome back, everyone. In this chapter on matter, so far we have talked about the definition of matter and also some of the early beliefs about the smallest units of matter, which we're going to come to know today as being the atom. But we're going to continue with section 3 right now, which is a few brief slides, and then we'll get into the atom in more detail. But section 3 is kind of going from the smallest unit of matter, that is particles of matter, being a theory, to the evidence for them actually existing. And so the idea of atomism, this word right here, that is the belief that there is a smallest particle of matter, is based on the assumption that these particles are in constant motion. They're constantly moving. Just like if you have a room full of people, they can't sit perfectly still. They're constantly jittering back and forth, at least to some degree. And atoms do the same thing, these smallest particles of matter. You can see this if you take a bit of food dye, or in this case, any kind of colored crystal that dyes water. Put it in water, even just a drop of it, and if you don't stir it, the dye will still kind of find its way around the water. Now, it certainly helps if you stir it. You're adding energy and you're adding motion to those particles, but the fact that these colors will kind of swirl around on their own and eventually completely fill the glass of water is evidence that there are sub-microscopic particles. I almost said microscopic, but you can't even see them with a microscope. Even smaller than microscopic particles that are actually jittering back and forth, causing this motion right here. We call this diffusion. All right, and this is supporting the idea of atomism, that these smallest particles are jittering back and forth and therefore can stir water even without you trying to do so. We also found in the 1700s, or scientists did, that if you burn material, say burn a piece of paper, all right, the matter in the piece of paper weighs different amounts before and after burning. So the assumption was that after it burns, something, or as it burns, something happens where these smallest particles combine in different proportions, which explains the difference in mass before and after burning. Aloha and welcome back, everyone. This is our chapter 1 on matter, and up to this point we've talked mostly about the definition, or probably better to say the description of matter, because it's very hard to define, but we can describe it. And also some things that support, or I should say, the early theories. Aloha and welcome back, everyone. This is our chapter on matter, and up to this point we've talked about the description of matter. We've tried to define it, although it's difficult to define, but we can certainly describe what matter is. And we've also talked about some of the theories, the early theories about the particle nature of matter. We're going to continue with that theme on some evidence for the particle model of matter, and then also talk about what those particles are. You probably know them to be atoms, and that's what this segment is going to be on today. Section 3 and Section 4 are going to be on evidence for the particle model and on atoms. So the idea of atoms, or the atom, or atomism is the idea, is based on the assumption that these particles are in constant motion. And discoveries about this led to the acceptance of the atomic model for the theory of matter. What is matter? Well, it's these little teeny tiny particles. Part of it was based on what you see right here. We call this diffusion. All right. The assumption that all these particles are constantly in motion is supported by the fact that if you drop some food dye into some water, it will actually it will swirl all around, as you see these colors swirling around right here, even without you stirring it. The food dye will eventually blend itself all into the water simply on the jittering back and forth of the particles of the water. We call that diffusion. And it's because these particles are in constant motion. Another discovery that kind of helped the theory that there is a smallest particle of matter, what we call atomism, is the fact that in the 1700s, scientists found that as they burn something, it weighs, or it has different mass before and after burning, which led them to conclude that some of that mass must have combined in different amounts. If it was all solid stuff, it couldn't recombine in different amounts and have different masses. But if it was small particles of matter, those particles could recombine in such a way that they actually weigh less after burning than before. And that supported the atomism, or the particle theory of matter. Furthermore, in 1827, Robert Brown, who was a botanist, now botanists, they study primarily, or I should say exclusively, plants. And so he was looking at plant cells, and if you've seen a plant cell before, it has a cell wall and this kind of little box that it lives in. And he saw fluid, excuse me, moving around inside the plant cell. Nothing was touching them, of course. He saw this fluid just swirling around and jittering back and forth, and was led to conclude that fluid must be made of smallest of particles. That is, the smallest bit of matter made of particles jittering back and forth. In fact, we've given a name to that jittering back and forth. We call it Brownian motion in his honor. And we see this smoke right here exhibiting Brownian motion. Now, I know that regular smoke, when you put out a candle, is kind of grayish, but this has been colorized right here so you can see it, much in the same way that we saw that food dye. But as smoke I should say swirls around, it exhibits Brownian motion. You can't predict where it's going to swirl because the air particles around it are jittering back and forth, and it causes that smoke to kind of just go any which way. So we call that Brownian motion, and that supports the particle theory of matter.